Welcome back to the channel. Hope you're doing well. Going to be a short video today. Actually going to be a series of two videos. First one, I'm going to show you how to solve a 3x3 system using Desmos, which, if I'm being honest, a little bit easier. If you don't have this paper in front of you, you can just pause the video briefly, write down the equation up here. I'll talk about how to get this matrix. And we'll do two more equations and two more systems in just a minute, and you can pause the video at those times also. I know this says we're using the TI Inspire. That's going to be the second video, but the matrices are going to be the same, so the setup isn't going to be any different from there. Okay, so we have this system. The first thing you want to check is that the x's and the y's and the z's are all lined up on the left-hand side of the equal sign. And then the solutions to each of those equations is lined up on the right-hand side of the equal sign. We've done this before, and this sets up what's called our augmented matrix. If you've done these by hand using Gaussian elimination, this should look familiar. But the nice thing is, like with technology, we can do this much, much faster than doing the row operations and stuff like that by hand, especially if the numbers have decimals or they're big numbers, something like that. So here's what you do, and again, this is the Desmos version. So what we do, so we go to this website here. It's desmos.com/matrix. If you're used to using the normal Desmos calculator, that does not have matrix capabilities. It's a separate one. So again, desmos.com/matrix. All you got to do is hit the button that says New Matrix. You want to change it to the appropriate number of rows and columns. In this case, it is 3 and 4. And then you're going to take your matrix and you're going to type in those numbers just the way they look, right? So that's going to be 3, 4, 5. I'm going to do this kind of quickly. 24.4, 6, 5, 2, 30.4, 3, 2, 1, and 13.4. Double check those numbers if you're anything like me and get a case of the fat fingers all the time. If you drop a sign or miss a decimal point, whatever, it's pretty easy. It's going to throw your solution completely off. So just do a quick check and make sure the numbers are all right in there. After that, you hit this little button down here that says RREF. That stands for Reduced Row Echelon Form. And you put whatever the letter is, in this case it's matrix A, and hit enter. And that's your answer, because if you know how matrices are set up, when you do these by hand, you may have just gotten these 3 zeros here. Well, that bottom row tells you what Z is. That is Z equals 0.95. This is your Y column, so Y equals 3.6. This is your X column, so X is equal to 1.75, and you're done. If you want to know what those are in fractions, you can actually hit this little key right here, and it'll give you the same answers in fractions, and you can go back and forth. Okay, that's really it. So again, you just type in the new matrix, change it to the appropriate number of rows and columns. You do RREF. Again, that stands for Reduced Row Echelon Form. You won't need to know that, and then it's going to spit out the answer. So let's do one more example of those real quick. Again, if you want to pause the video real fast, for this one, we do need to move these things around a little bit, right? So we need to have it lined up. So in this first row here, your matrix is going to be 2, 1, 1, 3. I move the 2x over, I move the z over, put them in order. The second row is fine, so 1, 2, -2, -4. And the third row is kind of fine. They're on the right side, but we need to do some rearranging. So no changing of signs. So it's going to be 3 for the x, and then -1, and then +1 for the y. And then this is going to be the augmented matrix that we use, right? So we do the same thing. So we go back to our Desmos. We can do another new matrix. This time it's matrix B. Whoops, one too many. Go from there. So again, we're going to type in those numbers, 2, 1, 1, and 3. and 3, -1, 1, and 9. You hit enter, double check them, make sure everything looks okay, and I think they do. RREF, B, and again, those are your answers. In this case, they came out clean. X is +2, Y is -2, Z is +1. Okay, so that's what you do. So again, you want to make sure that everything is lined up the way it should be lined up, as far as X, Y, Z is on the right, and then the solution on the left. There's a couple of special cases that I want to show you, just real fast. And I'm not even going to show you the paper on this one. I'm just going to show you, like, when you type in the matrix, what it's going to look like. So we're going to do one more. Actually, you can do two more real fast. So this matrix, and you want to type this in with me, you can. We got 4, -4, 2, and -14. We have 1, 2, 0, and 14. Oops, didn't get the last row there. And then we have 0, -3, 1, and -10. So that's my C matrix. If I do REF here for C, let's see, did I type those in correctly? 4, -2, -14. Oops, that should be a 4. Let me change that one. What I say about fat fingers, that's a 4, and then 0, 9. There we go. So if we see this, once I have the matrix typed in correctly, because I can be an idiot sometimes, you see my final row here is 0, 0, 0, 1. If you think about what that means we don't have any X's, no Y's, no Z's, so that says 0 equals 1. That does not make any sense. So if you see this situation, the other two rows don't even matter. If you see 0, 0, 0, 1 on the bottom row, that means there are no solutions. Okay? That's a no solutions case. Let me show you one more. So let's say you're doing a matrix and you have something that looks like this. So 0, 0, -3, and 6. 2, 1, -2, and +6 again. And then -6, -3, 0, and -6. Let me double check these, make sure I didn't make another goofy mistake. Yep, that looks good. And if I do the RREF for matrix D this time, now we see this. And we see that bottom row, 0, 0, 0, 0, all zeros. So what does this say? This says 0, 0 equals 0. Last time I checked, that's correct. So this means if you ever see this situation, again, the other two rows do not matter. If you see all zeros in the bottom row, that's going to mean there are infinite solutions. Okay? So that's how you do a matrix on Desmos. So again, desmos.com/matrix. You change your rows and columns, type in the numbers, double check them, make sure they're lined up correctly. If you need to do some manipulation, do the manipulation. And then just do the REF, name of the matrix, and it'll spit out the answer. And then the two special cases, 0, 0, 0, 1, no solutions, all zeros in the bottom row, infinite solutions. If you found this helpful or know anybody that would like to know how to solve a 3x3 matrix using a calculator, make sure your teacher knows you're using a calculator, and make sure you're allowed to do that. But it's a good way to check your answer, even if you do have to do it by hand. Until next time, stay safe.